Hey, how's it going, everybody? This is Pat Nappy here with another video in my series on SAT practice test number 2. This question is on the part 3 section of the test. This is the no calculator section, and I'm going to be going over all of the questions on this section and the part 4 as well. But for today, we're going to be going over number 8, so let's get started. Okay, so for number 8, we have a question that says n times a equals 360. The measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater than 50 degrees, what is the greatest number of sides it can have? Okay, so for this question, we're going to be given a number that is greater than 50. Rather than being given a straight number, they're telling us it's greater than that. Anytime you see this in a question, right, where you're given a quantity that is greater than another quantity or less than another quantity, you're going to be dealing with an SAT question that is asking you to maximize or minimize something. This is not a completely uncommon type of question on the SAT math section. I would say that each SAT math section has at least one or two of these types of questions. So what you can do on a question that requires you to maximize and minimize things is to test different values. So if we have a number like 50 degrees, which is kind of the lower boundary that we could use, right, for these exterior angles, we could use 51, 52, 53, anything greater than 50, but nothing smaller than 50. With this situation, start with that lowest amount, start with 50, and work your way up and see if you can get a sense for what the other part of the question is doing. Is that also going up or is that going down? So in this question, we are given the angle, and we're trying to basically figure out what's going on with the number of sides using this little equation. So if we take this equation and we plug in 50 degrees, let's start with that and see what number of sides we get. So to solve this equation, we're just going to divide by 50. Now, you can do this division very quickly by hand, right? The old school way, you can just do 50 into 360 and do that if you want. A quicker way of doing this using just sensible mental math would be to just sort of estimate that 360 is like 350. It's pretty close. 50 can go into 350 7 times. And we know that because 5 times 7 is 35, so 50 times 7 would be 350. That gets us pretty darn close. And we would have a remainder of 10, right? If we're only going into 350, we have 10 more units we have to divide into. So we end up getting left over with a remainder, right, of 10 over 50. And if we know how to do our mental math and simplify fractions, this is going to be 1/5. And if we want, we can actually make this into a fraction out of tenths, right? If we have tenths, we basically get our decimal places. So we would times by 2, you're going to have 1/5 equaling 2 tenths. And that means we really just have 7.2. Okay, so if we have a 50 degree exterior angle, then we would have exactly 7.2 sides for our polygon. The only problem with that is that you can't really imagine a polygon with 7.2 sides, right? Either a polygon has 6 sides, 7 sides, or 8 sides. So this is just sort of a flaw in the equation that they give us. However, remember that we're not really dealing with angles that are exactly 50 degrees, right? We're supposed to be dealing with angles that are greater than 50 degrees. Now, by virtue of the fact that 360 is divisible by 6 or 60, we should try that out as an exterior angle. What if our exterior angle was 60 degrees? This fits with the question. This is greater than 50. Let's see what we get for a number of sides if we do that. We should get a nice whole number, right? If we divide this 60, we're going to be able to say that 360 divided by 60, if you ignore these zeros at the end, is just like 36 divided by 6. You're going to end up getting that n equals 6. So this would be a sensible number of sides. And let's just kind of compare these and think about what are the possibilities that we might have as the angle goes from 50 degrees up to 60 degrees? So if at 50 degrees we're at greater than 7, we're at 7.2, and at 60 degrees we're at 6, somewhere along the way we're going to get exactly n equals 7. That fits in between these two numbers. And so that's going to end up being our answer. There is some number in between 50 degrees and 60 degrees as an exterior angle where the number of sides would be exactly 7. And so we're going to go ahead and pick C to be our answer. And if you think about it, the way that we were able to do this is by just testing out different possibilities. So if we're given a number, which is essentially a minimum, right? We have to have something greater than 50. We can just work our way up and get a sense of what the other variable is doing. And that's it for this question. If you found this video helpful, definitely give me a like or subscribe to my channel, and share this video with anybody who's struggling with SAT math prep. If you have a better or quicker solution to this problem, definitely leave me a comment. I'm always interested in finding out better and quicker ways to do these questions. And if it is quicker, I will re-edit this video so that it includes that solution. That's just going to help everybody, and we always want to crowdsource the best possible solutions. As a reminder, I also offer one-on-one SAT prep and group SAT prep on my website, PNLearning.net. I left a link in the description, so find your way over there if you think that's something you might benefit from. And that's pretty much it for number 8 here. And that's it for this video. I will see you guys in the next one.